Engineering and technology have always been the driving forces reshaping our world, accelerating history's progress and powering the evolution of human civilization. Today, as China rises as the world's second-largest economy and a global manufacturing leader, it's also proving its unmatched engineering strength, earning global recognition as a true infrastructure powerhouse. A wave of astonishing megaprojects has put China's national ambition and creativity on full display. Amid global economic shifts and China's new development phase, these monumental projects, defined by their enormous scale, technical complexity, massive investment, and lasting impact, span transportation, construction, water management, energy, and even defense. In just a single decade, China has built and launched over 45,000 kilometers of high-speed rail lines. For comparison, Japan and Europe took nearly 3 times as long to build theirs, and their total networks are still only a fraction of China's. Today, China's high-speed rail network surpasses the rest of the world combined. Technologically, it's gone from importing to leading, ushering in the high-speed rail 4.0 era. The Three Gorges Dam stands as the world's largest and most complex hydropower project. The south-to-north water diversion project, humanity's boldest interbasin water transfer. And the land reclamation in the Nansha Islands has been called nothing short of a miracle of nature's craftsmanship. Among these engineering marvels, one pushes the very limits of human ingenuity: the world's largest island-to-mainland connection, the Shihumen Bridge. From above, you're about to witness one of the boldest feats of modern engineering, a structure that unites sea and land in a single breathtaking sweep. Its 1,650-meter main span stretches effortlessly across the waves, holding the title of China's longest span bridge for 10 straight years. But that's only part of the story. Together with the Jintang, Taoyaomen, Xiangjiaomen, and Chenggong bridges, it forms a continuous chain of megabridges nearly 50 kilometers long, connecting once isolated islands into a single thriving region. 9 years later came the 8-kilometer Yushan Bridge, linking Yushan Island to Daishan Island. 12 years after that, the 25-kilometer Zhoushan-Daishan Bridge connected Daishan to Zhoushan's main island. Add to that the 32.5-kilometer Donghai Bridge linking Shanghai to Xiaoyangshan Island and the Liuheng Highway Bridge now under construction, and what you get is a vast expressway network built right above the ocean. The result? China gained the world's busiest cargo port, the second-largest offshore green petrochemical base, and its very first major deep-sea fishing zone. This isn't just a bridge, it's a super connection that reshaped China's coastline and redefined what's possible in modern engineering. After mastering cross-sea bridges, China turned its sights underwater toward a new frontier: undersea tunnels. Enter the Jintang Undersea Tunnel, the world's longest high-speed rail tunnel beneath the sea. Stretching 16.18 kilometers in total, with 11.21 kilometers of shield-driven tunnel under the seabed, this project is, honestly, an absolute engineering masterpiece. Its cross-section measures 14.5 meters in diameter, as tall as a 5-story building, wide enough for 2 high-speed rail tracks. At its heart is the giant shield machine Dinghai, its 15-meter cutterhead tearing through rock like the jaws of a colossal beast. Guided by China's Beidou satellite navigation system, it advances with pinpoint precision toward another giant machine, Yongzhou, boring in from the opposite direction. Deep beneath the seabed, the two will meet with accuracy measured in millimeters. Why is the Jintang Tunnel hailed as #1 in the world? One word: speed. Its design speed is 250 kilometers per hour, far faster than the Channel Tunnel between Britain and France, which is 160 kilometers per hour, and Japan's Seikon Tunnel at 140 kilometers per hour. By any high-speed rail standard, Jintang's scale is unmatched worldwide. But length isn't the only challenge. The tunnel lies 78 meters below sea level, where pressure is immense. Engineers had to conquer 28 geological layers, constantly switching between rock and soft soil. To handle this, they added water injection pipes for sticky clay, reinforced seals against high pressure, and upgraded the drive systems for long-term stability. Construction uses a dual shield method. Yongzhou advanced 4,940 meters from the Ningbo side, and Zhuhai dug 6,270 meters from the Zhoushan side. Why the difference? Because the geology isn't uniform. Solid rock on one side, softer soil on the other, so digging had to be asymmetrical. Their meeting point was chosen within a stable rock layer, the only way to ensure absolute safety and precision. Accuracy here is everything. Even a small surveying error can multiply over distance, and one mistake could leave you with two tunnels that never meet. To prevent that, engineers deployed 6 Beidou satellites, connected directly to the machine's auto-navigation systems, constantly correcting their course in real time. In the end, alignment error was kept within 2 centimeters, a near miracle of precision. Then came the final challenge, removing the machines. Once they meet underground, there's no exit ahead and no turning back. The solution? Shedding the shell. The shield machines are dismantled piece by piece and pulled out, while their steel shells remain inside, becoming part of the tunnel's permanent structure. According to plan, the Jintang Undersea Tunnel will be fully bored through by 2026 and open to traffic with the Yongzhou Railway by 2028. Once complete, travelers will reach Zhoushan from Ningbo in just 30 minutes, ending centuries of isolation for the island region. And while officials don't say it outright, many see a larger goal behind it. This tunnel could be the test run for a future Taiwan Strait tunnel. If China ever attempts that crossing, the Jintang project will have been the ultimate rehearsal. So just how advanced is China's underwater tunnel technology? Let's look at another world-class example, the Hong Kong-Zhuhai-Macau Bridge Tunnel. Here's the big question. The ocean is full of water. So how do you build under it? And how did Chinese engineers manage to construct a 6.7-kilometer underwater tunnel buried 40 meters below the sea? At first, engineers considered using tunnel boring machines, but TBMs demand extremely stable ground conditions, and that meant the tunnels would have to be dug much deeper than the design required. So, they needed a different solution. The goal was to build a colossal sea-crossing bridge linking Hong Kong, Zhuhai, and Macau, a project now celebrated as one of the 7 wonders of the modern world. The answer lay in immersed tube tunnel technology. Here's how it works. First, engineers dredge trenches along the seabed. Then, massive precast concrete tunnel sections, known as immersion tubes, are lowered into those trenches, aligned with extreme precision, joined together underwater, and finally covered with layers of sand and gravel. Each tunnel section is 180 meters long and weighs around 76,000 tons, roughly the size of an aircraft carrier. Inside, each one holds 2 3-lane carriageways and 2 service tunnels. Chinese engineers had to lower and align every single tube one by one. But casting a single 180-meter, 76,000-ton reinforced concrete piece in one go was practically impossible. The workaround? They divided each tunnel segment into 8 smaller parts, prefabricated them in a special factory, and then joined them into a single 180-meter unit. In total, the project used 330,000 tons of steel and 2 million tons of concrete, enough material to build 8 Burj Khalifa towers. On the uninhabited Niutu Island, more than 3,000 workers constructed a massive production base in just 100 days. Its only purpose to build the 33 immersion tubes required, 2 each month, each one weighing 76,000 tons. After more than 1,400 days of non-stop work, almost every tunnel section was ready. The final piece, E30, was carefully lowered into place. Steel cables slowly guided the enormous section down to the seabed, while engineers on the surface monitored every movement in real time. After 26 hours of meticulous adjustments, E30 was finally locked into position. Divers then descended to the ocean floor, performing millimeter-accurate measurements to confirm the alignment was perfect. Once verified, the last joint was sealed, and the world-famous Hong Kong-Zhuhai Macau Bridge Tunnel was complete. This was far more than just a tunnel. It was a statement about speed, precision, and ambition. You know, one netizen actually compared China's rise to the way humans learn. You get smarter through both success and failure. China, they said, is like a sponge, constantly absorbing and improving upon technology. And honestly, many of these mega projects aren't about showing off. They're about making life better. As one user put it bluntly, the US spends over $1.5 trillion on defense instead of infrastructure. Imagine what both countries could achieve if they worked together on construction. A foreign commenter added, "These megaprojects showcase China's engineering skill and determination, reshaping its landscape and connecting its vast population." But such progress comes with hidden costs. These projects often involve large-scale land acquisition, deforestation, and the displacement of local communities. The environmental consequences are also immense, from air and water pollution to habitat loss and even contributions to climate change. Take the Three Gorges Dam, for example. It displaced millions and altered the Yangtze River's flow. Or the Belt and Road Initiative, which has raised environmental concerns in partner countries. While these projects promise economic growth, they often raise issues of social equity and human rights. Forced relocations, labor exploitation, and limited transparency have fueled debate about their true cost. Others see things differently, as part of a much larger story. China has been asleep for a while, one commenter said, but now it's waking up, and no one can stop it. Construction, they say, runs in the bloodstream of the Chinese people. They've been building for thousands of years, and they're still building. For them, the sky truly is the limit. From cross-sea bridges to underwater tunnels, from high-speed rail networks to massive water projects, China keeps redefining what's possible in human engineering. These are not just steel and concrete structures. They are symbols of ambition, vision, and willpower. Naturally, such projects ignite debate around the world. Some marvel at China's speed and precision, while others question the social and environmental toll. But one thing is undeniable. China has proven that the future isn't something you wait for. It's something you build. So, what do you think? Are China's mega projects the next chapter of human civilization, or a massive gamble? Share your thoughts in the comments below. China has pushed the boundaries of engineering again and again. These mega projects aren't just transforming China, they're reshaping the world. And this is only the beginning. In our next episode, we'll take you deep inside an even more ambitious strategic project, the Pinglu Canal. How will this canal of the century transform the economy of southwest China? And why are foreign viewers comparing it to an alien base straight out of science fiction?